Hello, everybody. Yeah. How's everybody doing? Cool. Do you saw that slick Slack plugin that we did on the live streaming? That's pretty awesome. So yeah, one of our office manager, he actually wrote the whole Slack plugin so that we can actually initiate a live stream on the event from Slack, which is pretty interesting. Yeah, so everybody, thank you for coming to PyData. Yeah, just want to start the event with giving a few shout out. So PyData is basically an event that started with an organization called NumFocus. So we do Python things, we do data things, but basically it's a kind of or logical gate that if you're interested in data or you're interested in Python, you're really welcome in our community. So anybody know where this picture is at? Seattle, that's right, Space Needle. So in fact, if you're interested in either you're already deep into the community or you're interested in knowing more about the community, there is actually a PyData Seattle coming up soon in the start of July. So it's going to be a 3-day event, 1-day tutorial and 2-day speaking event. It's hosted by Microsoft. They've got, if anybody been to the campus upstairs, the one in Redmond is even better, obviously. So it's really recommend to go and check it out. So I know there's a few people in Vancouver that's already going, so we're kind of like organizing a road trip style event. So if you're interested in this, definitely go to the meetup group and sign up, get a ticket, and we can organize some logistics on there. So maybe go there together, have fun, do a road trip, have a Vancouver present there at PyData Seattle. Another event that we are actually happening in this summer is basically we are hosting the first AI Hackathon series in Vancouver. So the Global AI Hackathon is basically a 3-day event where you start on Friday night, you have a few people that's talking about the ideas they have, what data they have available. And from there on, it's basically a challenge, kind of like 2 days hacking challenge that you can build. And at the end of on Sunday, we basically get together, do some presentation, and enjoy some beer together and have fun. So yeah, this is an event that's like open to any level of people that's interested in data. So we actually on Saturday morning, we're going to organize some sort of like sessions to introduce people to different tools that we use in the industry to analyze the data. So if you're interested in either getting into learning more about the data science, data engineering industry, or you're already deep in it that you think you can actually like help out other people to learning more, definitely come and join this event. And this event is free to sign up, so definitely encourage you to sign up if you're interested in joining. One more thing, actually. So right now, for PyData Vancouver, we are actually looking for co-organizers, which can, if you're interested in hosting the event, say on your space, or you're interested in helping out with the community, please give me a shout. We'd love to chat to you and kind of get your help, as well as speakers. So if you've got some interesting topic to share, please, I'm always open to listening to cool ideas and learn from others, and as many of us are. So please do let me know. Don't be shy. I think right now, this is a really inclusive community here that if you are, for example, I'm sometimes a bit shy about public speaking, it's a great place to start doing that and step up to maybe doing a big conference. So if you're interested in speaking, definitely let me know. So why are we all here? Tonight's speakers is Anish. So I know Anish for a while already from Stats. So he's the lead data engineer in Stats, and basically he a lot of the technology on Stat is built from there. And whenever I talk to Anish, I learn a lot from the stack that he's building, different interesting technology that he fight with. So tonight he's going to talk about some of the experience he has with AWS Batch. So yeah, welcome Anish.
Thanks, Boris. All right. So today I'll be talking about distributed scraper architecture using AWS Batch. I'll talk to you guys a bit about what we do at Stat and stuff to sort of explain the problem that we're dealing with here. But essentially, we build a collection and analysis pipeline at STAT. We've been doing it for 6, 7 years, and I work with the team on projects like that. So what I'll be specifically discussing today is I'll be talking about more into why care about a distributed scraper, right? Like what does it actually solve for STAT? What business are we in? Then I'll discuss our actual current architecture for a scraper, because we have one. We have one that we've been using for, I'd say like the last 4 or 5 years, right? And we've seen sort of some problems with it. And so I'll be discussing more about those problems, and then talking about AWS Batch and how it sort of solves some of those problems. So discussing a few key concepts behind it and stuff like that. And then I and my team, we worked on a proof of concept for a new architecture. And we'll be going into that, and then going into what's next for the project, right? Like this is just POC, so how do we actually plan on bringing this into production? Most of this talk is going to, as the presentation says, as all of the slide says, is going to focus on architecture, right? Obviously, code and configuration are an important part of any distributed system or data pipeline. It doesn't work without that. I won't be talking much about it. But there is another talk that I'm doing at another meetup where I'll be talking about that stuff, and I'll tell you guys more about that. So yeah, what do we do at STAT? This is our mission statement, right? So it says we unlock insights into complex data to give people a competitive edge in search. So what does it actually mean, and how do we do it? I've searched here a keyword, data pipelines. Like you guys must be searching on Google all the time. And this is the results page that it returned to me. Now, in here, you see that the first thing that Google is trying to do is trying to answer. It's thinking that you probably want to know what a data pipeline is, and trying to give you a paragraph answer to answer that question. Then it's sort of trying to be helpful, and it's trying to suggest a few other questions that you might have about data pipelines. And then after that, you see all these, what we call organic links. So at STAT, we crawl a whole bunch of these keywords, lots and lots of them, every single day, get this HTML from Google, we parse it for as much information as we can. So we classify all these different results type. Like the first one will be an answers, the second one will be like questions, and all after that you see organic results. After we parse it out, starts this whole process of analysis, where we try to figure out various things, right? Our clients will be, someone will come to us and be like, all right, tell me where I rank. So that's like the basic set of analysis you can give anyone. But other than that, there's a lot of comparator analysis to tell people exactly how they're doing against the competition. So data collection and then data analysis after that. Now, these are just some numbers, and all I'm trying to do in this slide is to show you guys. I mean, you can call it whatever you want. You call it a big data, large data, but it's a fairly big scale thing. We're crawling like 15 million keywords daily, crawling that on all the 3 search engines, Google, Yahoo, and Bing, and it results in quite a bit of data, right? It's 750 gigs of compressed HTML, and then JSON and MySQL data that goes into our databases. This is just a very high-level architecture diagram. Or what I'm just trying to show here is that if you think of it as like 4 basic components, the 4 components being a web application. So after all the data is in the database, it's used. It's a Ruby on Rails application that customers log into, and they see various tables, graphs, etc., from all the data we have collected. Some people, they want to analyze the data themselves in their own different way. And so we have like a SQL reporting engine, CSV reports. I won't be focusing on those 2 components at all in this talk. Primarily, the talk is about the distributed scraper part of this. I'll kind of be touching on the analytics just to sort of showcase how we think of it as being a different problem than the scraper. So let's get into that. This is, like batch computing and the whole idea behind it. Conceptually, we are viewing it as 2 separate problems in terms of scraping and analytics. From the scraping side of things, we are viewing the problem of batch computing as being job parallel, right? And what I mean is it's like 15 million asynchronous jobs that we queue up daily that go through a sequence of like Spider. That's where we get the HTML. We put it into an HTML store. Then it goes into a parser that parses out that HTML and puts into Mongo and Dynamo, and ranker and inserter, right? But they're like, the jobs are essentially the same. It's like the same piece of code. The different params are the keywords. They're like 15 million asynchronous jobs. It's not like the 12th Spider job depends on the first Spider job, right? The MySQL database there is where we grab our keywords from to crawl, and so that's what goes into the Spider, and then we insert back the ranks into MySQL database as well. Now, this is different than how we view the problem conceptually of the analytics piece. That we view it as data parallelism. And by that, what I'm trying to say is after we have collected all the data, right, from our, like we have spidered it, we have parsed it, and they all are like in a JSON format, let's say, or in the MySQL database, we will then do a whole bunch of competitive analysis on it. In this, I'm showing you one of our processes. It's using Spark Scala on EMR, Elastic Map Reduce. Right? And then it's like this, the whole idea here is that you have all the data, you might split it up in a map reduce operation to do analytics on it, but it's different than the idea of processing a whole bunch of jobs asynchronously in a queue. So actually, does anyone have any questions about that stuff? I'm going to stop at every section and ask questions because the doc sort of builds up in concepts. And so I thought if you don't have questions, it's fine. Go ahead. Yeah.
Why do you need to do it daily? Like, do such results change daily for those?
Yeah, so that is a business requirement. A lot of our clients, they do believe, and it is true, as a matter of fact, that they do change daily. It's like, all 15 million might not, but, let's say, I don't know, I'm just like making up numbers here, but like a million or 2 million might, right? But a different 1 or 2 million might change the next day and the next day. So they like to see like patterns and trending lines, which is very important for them. And Google changes their HTML quite a lot, right, too. So that's important as well. So, yeah, go ahead.
So every day you browse keywords, and are you calling Google API or are you using a lot of proxy servers to do that?
We're using a lot of proxy servers. We're using like tens of thousands of proxy servers to do it. Yes, so we have, that is a part of our intellectual property, so I can't really disclose exactly how we're doing it, but we have a way, like we have reverse engineered, faking locations. And our results are pretty accurate. Like we tested a lot, so I can say it's pretty accurate. Yeah. Yes. So the personalization, yeah, we cannot account for that fact. It's more of an idea for like the clients that we work with. They actually want to see non-personalized results because they want to see for a general audience how that would appear to be. Okay. Yeah. Lots and lots of problems. Yeah, like many times Google has shown us captcha pages, not wrong results in their case, but just given us results from a different location, for example, right? Because we were unsuccessful in doing this reverse engineering fake operations. It's happened multiple times. They do block people, and yes, they have blocked us by giving us a captcha page. We see it, just to elaborate a bit on that, it's not like there's a whole SEO industry, right? And a lot of people are doing this. They're aware of this. What they're actually trying to do, and obviously this is me being hypothetical, but like over 7 years you have some experience, is they're trying to block people who are like these ad bots, who click on ads and screw up people's spends and stuff. In that whole process, it's hard for them to distinguish us from those people who are actually trying to do some nefarious things. So we get caught up. So we do get blocked. We have ways of like throttling and like smart IP queuing mechanisms, to sidetrack that. All right. So how do we do this right now? The architecture of our current scraper. This is going back to the same diagram, right? So what I'm going to be doing next, and why I put this here, is because I'm going to be talking through how the spider works, and then how the parser works, how the ranker and the inserter works. So let's start off with the spider. There's a lot of logos here, right? I've tried to label them all. There is a reason for a lot of logos, and we'll talk about them, and it'll be obvious when we discuss the problems. I'm going to start off from the right here, from the data source, which is MySQL, where all the keywords are, the 15 million keywords. We pull them into a process, or we've named it. We've called it Skipper. It's our process that queues things. It's like the captain of the ship, because without it, there's no jobs for anything to run, nothing to work on. And that is just a Ruby worker. It's just a code that pulls things from MySQL database and puts it somewhere, right? And it's on an EC2 instance. It puts it into a spider queue. That spider queue is something that Redis is the key value store that we use, right? A resqueue is a Ruby library that works on top of Redis. It basically makes this interface of queues for you to put jobs into and pull jobs out of. So our resqueue is hosted on EC2 instance. For Redis, we use Amazon's Elasticache. Redis is cool, it's managed. We don't have to worry about scaling it. So yeah, the queuer, the skipper, it puts jobs into the spider queue. Now we have the same idea, and architecture-wise, a Ruby worker. It's not one, it's a set of them. I believe 500 to 1,000 of them running on a bunch of EC2 instances. I've just shown 2 here, but there's like about 4 of them. They pull jobs from the spider queue, crawl Google, Yahoo, and Bing, grab the HTML, and put it somewhere. The somewhere that they put it in is a file store that we have just configured ourselves on EC2 using EBS volumes. After they're done and they get that HTML, the spider has done its job, right? It's done what it needed to do. It queues up a job for the next thing being the parser. Now, the parser, very similarly, is a bunch of Ruby workers that are hosted on lots and lots of EC2 instances, gets the job off the queue, grabs the HTML, it parses it. Right? It figures out all the different classifications of the results on the HTML. It converts it into a JSON representation of the SERP, puts it into Mongo, which we're hosting ourselves on EC2 instances, and it also puts it into DynamoDB. Mongo is sort of one of those things that we started off back in the day, like 5 years ago. It wasn't really scaling well for us, so we just use it as archival storage purposes, just like a backup. Dynamo is what we're actually going to use for the next step, which is the Ranker. So Ranker, the same idea. Lots of Ruby workers working on lots of EC2 instances, pulling jobs off the Ranker queue, getting the JSON representation from Dynamo. It puts it into Redis. You might wonder why it puts it into Redis. It's because we are inserting lots and lots of data into MySQL. People who have dealt with this much amount of data might be aware that if you're inserting one by one rows into MySQL, you'll kill it, like it just die. So we are batching our inserts, and that's why we put it in Redis to store it until we are ready to do that. Some of these problems are probably already obvious, right? The system is like, all of it is self-managed by us. It's mostly hosted on EC2 instances. We have something called like Blue Pill, which is like Monit. It's making sure our Ruby workers are working, but it can crash. Google changes their HTML all the time. So when they make it harder to parse stuff, just because they've decided to add a whole bunch of stuff on HTML, we need to add a lot more parser workers. It's not very easy. It's hard to scale that stuff. I mean, it's easy enough to start a bunch of full EC2 instances and add the workers in, but the downstream effects is what kills us. I mean, we've got a pretty good handle of it right now. Back in the day, I can tell you guys it was crazy, right? Because you add in just new EC2 instance, just 40 workers, right? It's not even that much because you already have like 400 running. But the write throughput will increase, and you have to account for that and make sure that your Mongo can handle it. Right? And if it can, then the rankers are not going to function. It's expensive because it's self-managed. I mean, we finish our crawl. We don't take the full 24 hours to do this 15 million keywords. We try to do it in less than that, just to give ourselves some leeway. But if we leave it running, it's like it's too much work. Turn it off and turn it back on again. So those are the current set of problems that we have. Now, the whole idea behind this is we want to rebuild our architecture, redesign a new crawl. So these are a few other things that we like to do as well. We want to be able to run jobs. This is actually a business requirement. A lot of our clients want this. We want to run jobs with different frequencies. Some clients, in fact, even want the keywords to be run more than once a day, a few times a day, because some keywords are very volatile. Some people are like, well, we know that these keywords are not really changing that much, so we like to run it, in fact, weekly and save some cost, right? Like we can charge them a reduced amount of fee for that, or run it monthly. So you want to run jobs with different priorities. We want to know the status of any job at any time, because right now how the whole thing works with Redis and Rescue is we queue up all these 15 million jobs, and we're like, cool, all right, the queue is going down. We look at it. We have monitoring tools like Scout and Kibana, but we can't really tell what the status of a keyword is at any one point. So like when the crawl is finished at the end of the day, we are like, all right, let's just, all the 15 million jobs seem to have finished. There's no errors. Maybe let's run it once more and ensure that everything was caught, right? So we don't really have an idea of the status of a keyword at any point. If we redesign the whole thing, we want to have like a nice API layer, so we can easily access things like the reporting service and stuff can access this crawl much more easily than through the databases like it does right now. So back to this whole idea about job parallelism and parallelizing data processing, right? So the way we want to think about this for the future and use AWS Batch and redesign architecture is we really think the spider and the parser are the things that we want to treat as parallelizing jobs. For us, it's particularly important to do it that way because our spiders and our parsers, we were just discussing this whole Google blocking issue, right? Parsers can fail because HTML changes. We want to know in real time when that happens and be able to fix that issue. So you want to run asynchronous jobs through a queue. The data processing, the stuff like the Ranker, comparator analytics, we're like, it's fine. It's all under our control. Once we have all the data, we'll run it through something like an EMR process. So that's how we want to treat these things going forward. Any questions about that? No? Okay. I'll move on to AWS Batch. So and this is the definition of batch computing. I already sort of talked about this. The whole idea is just run asynchronous jobs across many different computers, right? You want to, like in our case with the spider and the parser and the ranker, you want to take account job dependencies, right? Such that the parser depends on the spider job being finished, right? So that's what batch computing is, just like a definition. What do we need to run batch computing jobs? Now, I'm talking about like AWS stuff here. These can easily be mapped to like something like Azure or Google Cloud. We are all on AWS, I'm using those things. So the first thing you need to run any sort of batch computing thing is you need an EC2 instance. You need some sort of computing resource to run your job. The next thing you need is the queue, right? So SQS is a good queuing system. Next thing you need is a scheduler. The scheduler, the whole idea behind a scheduler is you want to know the status of your jobs. You want to know which ones are running, which ones are in a queued state, which ones have failed. You want to know which jobs are dependent on what. So that's the whole concept or idea behind a scheduler. Additionally, what you might want is auto-scaling. So like in our case, if the parsers are behind, you sort of can set up CloudWatch alarms or use SNS notifications to be like, okay, our parsers have more jobs in the queue than expected. Let's start up some more parser workers, right? So that's like sort of like automated management. You don't have to go in and start up workers yourself. You kind of ideally want them to be managed. You can use ECS containers to do that. They start up all these Docker instances. They shut them down when they're done, right? Additionally, save cost. Amazon has this thing called Splot instances, which are different than on-demand instances. They are like this additional capacity that Amazon has. If you can hook into that and use that to run some of your batch computing jobs, it's just money saved. So yeah, these are the basic things that we need, and then these are the automation pieces. And that's it, actually. That's what Amazon Batch is. They've just used all the stuff that they had previously. They saw that their clients were using all these different components that were available to set up these batch computing infrastructures for themselves. So they're like, we'll create it for you, and hopefully you'll spend more money with us that way, right? These managed batch instances the cool thing about it is they can be optimized. They can be optimized for cost or time. So you can program it to be like, I want all the jobs in my queue to finish in 2 hours. Or you can be like, I don't care if they finish in 2 hours or a day, but I only want to pay $100 for it. So it lets you program that in, and I'll talk a bit about how that actually works. So these are some AWS batch concepts. I'll be talking through each one of them. This kind of build on top of each other. You start off with the job, and then it goes on from there. So let's just start off talking about job. Job is just the code. This is the code that you need to run on your compute instance. Right? You can put it in batch in a zip file. I wouldn't recommend that. You can put it using, you can bake an AMI image. I kind of also wouldn't recommend that. I mean, you can, but it's kind of a nightmare to maintain those AMI images. What I used for the POC and what I would recommend is Docker, right? You can set up Docker repositories. You can use ECS to maintain versions of your code. Why I have the Code and Coffee logo is Code and Coffee is a meetup. I was saying earlier that I'll be talking about the code and configuration stuff in a different meetup, and that's what, it's going to be at the same place here at Mobify on June 22nd. I'll be talking about how the code and configuration for all of this is set up. So from there on, we have a job. We have our code. Job definition is the next thing. In this case, what AWS Batch requires us to do is set up resources. What is the CPU and memory that the job requires? The CPU stuff is based on this whole thing about Docker and something called CPU shares. I won't expand on it right now, but I can talk to you more about it if you're interested in afterwards. But essentially, you define the requirements for your piece of code to run. The param stuff is optional, obviously, but it's like for our case, we need to define what keyword needs to be run. So that's like, I've just put in a syntax there, ref : keyword is a param that you can put in the job definition. And retries, job can fail 2-3 times. You might be okay with that, so you can configure that in. After it fails more than that many times, it'll end up in the queue as a dead job, and you can investigate it. So job definition, now we need somewhere to run it. You can run it in compute environments. Compute environments essentially are EC2 instances. They're managed. What managed means is that AWS will set up the compute environment for you depending on your cost or time optimization, whatever you have specified. It basically will run Docker instances for you on there. What you need to sort of choose is if you want to use on-demand instances or spot instances, and then basic stuff like roles, permissions, and security, like all the other EC2 or ECS stuff needs in Amazon. The job definition and the compute environment, they both need this CPU definition, right? So in the compute environment, you basically define the mix and min and max CPUs per compute environment. And based on your job definition and what you want your compute environment to be, for AWS to set up for you, it'll decide the number of Docker containers that it can run on that compute environment. You don't have to choose a particular instance type for the compute environment. You can just select optimum. And how it works in my POC when I tested it out, it defaults to choosing the biggest size. So if I have a compute, like in my case, I had a CPU bound thing, I went optimum C. It is not the most efficient thing. I think they have to probably work on better algorithms to figure out the optimization. But I can tell you, it's like, I think they are like, well, the client or the person using this system will probably be really unhappy if we choose a smaller one and it fails. So we will choose a bigger size for them. All right, so now we have job definition, and a compute environment. The next piece that we need is a queue. This part is, in my investigation of my work here, I thought this was the coolest part, and I'll tell you guys why. This particular slide doesn't explain it, but the next one's will. So in a job queue, you can define dependencies in the spider and the parser jobs in our case, right? What jobs are dependent on each. You can also set them up to be priority based. So they have a set of 10 priorities. You can choose a queue to have a priority of 1 through 10. This is the part where the priority queues with the compute environments works really well together. The mapping is like many to many. So what I could do, and what I'm trying to show in this case, is I can have 3 different priorities of job queues, 1, 2, and 3. I can hook them up to the same compute environment. And so it will pull jobs, firstly, from the first one, and try to finish them all before it goes to the next job queue, and so on and so forth. You can also do it this way, where you have just one job queue, but you have 3 different compute environments. In this case, possibly what you want to do is the first one can be an on-demand one that you've optimized for time. But then you're like, all right, I want this thing, this job queue to be empty in like, say, 16 hours. But, there could be spot instances that are available for cheaper. And so I want to create another compute environment just on spot instances. And if it gets scheduled and created and meets your spot price, then the job might finish in 10 hours or something, and you only pay for the resources that it actually use. So this is another cool way to set it up. So yeah, so we have a job definition, job queue, a compute environment. The last bit here is a scheduler. The scheduler, I like the fact that they have several really informational statuses. They have like 8 of them. It tells you all the way from the fact that, hey, your job was submitted with the right params. It's in a state that can be run successfully, to the fact that, oh, okay, I have found a compute environment to run these jobs in. And then from there on, it's like the job is running, it's successful, or it failed. There's also some commands there that I've listed at the bottom there: list jobs, cancel job, and terminate job, that are helpful in figuring out and like canceling jobs if you need to. All right. Any questions about AWS Batch? No? Yeah, go ahead.
How do you handle the debugging of these things? Like, do you have some staging environment with less nodes? Or can you submit this and you have a bug?
Yeah.
Everything crashes and closes the document?
Yeah, so there's 2 different ways I was using there, found interesting and cool about it. So you have access to SQS and ECS, right? Like, it shows you under the hood that they're running. You can, in fact, use ECS and just run that one job and look at if it's working or not. Like, when you're developing, you might want to do that. So it exposes all these different components that you can independently investigate. Other than that, how it actually works is whatever you're putting to standard out and standard error, the scheduler logs them all. If you really want, you can go on their visual interface and look at it. Or you can set it up easily to go into S3, and then you can set up the S3 bucket to use something like Kibana or one of the other monitoring tools and investigate your logs. So that's how it's set up. Any more questions? So one other thing I'll say, I don't know if I mentioned it. AWS Batch by itself, they don't have like an extra cost or anything associated with it. It's basically all the EC2 and the SQS and stuff. You pay for whatever you use there. All right, so new architecture. This is just the old diagram, so I won't go to explain it. It's the exact same thing that we had before. I'm showing the spider here. So the first thing I did was I got rid of that the Ruby, the skipper thing that was running on EC2 instances, the Ruby worker. I replaced it with the Lambda function. Right, right now, we are running our jobs, 15 million jobs per day. So the Lambda function is just set up on a scheduler to run once a day. It's putting jobs somewhere. Now, obviously, I don't want to put this into the Redis rescue queue. It defeats the purpose. So getting rid of that, and then have a big block there in this particular slide, which is AWS Batch. Now, here, like I was talking about earlier, we want to treat the spider and the parser. We want to do both those jobs in AWS Batch. So the outputs you want are the HTML from the spider and the JSON into Mongo and Dynamo from the parser. So internally, this is the setup that I had. I have just one SQS queue, because I'm just trying to replicate what we have right now, right? So it's just one priority. 2 compute environments, one with the spider code in ECS, another with the parser code in parser ECS. They're pulling jobs. The parser jobs have been defined when I submitted jobs from using Lambda into SQS queue. I made the spider jobs, the parser jobs dependent on the spider jobs, right? They're doing their thing. The spider is outputting stuff into the HTML, into the file store, and parser into Mongo and Dynamo. Next, what I played around with was I added another compute environment for the parser. This is the one that's running spot instances, right? So I'm like, hey, like Google changes the HTML sometimes. It just gets more expensive as a normal course. I don't want to worry about that too much. It's going to be a few extra dollars every day. It's fine. If it meets my spot price, I'll just pay the additional cost. So the parser ECS thing hooks up and pulls from the same queue. but it's for the additional load. Next, to sort of solve this problem about storing states, and this is sort of, this part is outside of batch, actually, right? It's nothing to do with batch. I was storing the states of the keywords in DynamoDB. So every time the spider job would finish, right, it would say that, hey, the keyword has been spidered, your HTML is there in your cache, and this is a link to the HTML. The same for the parsers. The states have been stored in DynamoDB. So going back to our problems and how we're trying to solve them, the many points of failure, we're trying to solve them by reducing the complexity of the system, right? Using AWS batch its core components of ECS, not having all this Redis, REST schemas, not having Ruby workers running on multiple EC2 instances, just reducing the number of components. Hard to scale portion, we are auto scaling it based on demand. That's the managed EC2 compute environments. And finally, yeah, the same thing to do with the expensive cost, right? You can use spot instances. The other stuff here, running jobs with different priorities. I haven't done this in my POC yet, but like we can set up the priority queues. In order to do that, I can have two of these SQS queues. For the status of the job, DynamoDB, and creating an API. Again, like I haven't done that, but we have DynamoDB, we have all the keywords and their status is there, making a simple API using Lambda to expose that to an external service. Any questions about that? Yeah, go ahead. The original HTMLs. Yeah. So we store it, and that is, I haven't really changed that with this system. It just goes into, we have, it's kind of like a file store. We have multiple EBS volumes hooked up to a EC2 instance, and we expose it through a web interface, just with Nginx running on it. So like, it's like HTTP put requests, it's putting the HTML in there, and get requests to get it out. That's all it is. That's what it was in the older version. I have the same thing right now. We are actually, to your question, we are thinking of, and we probably will do this, we'll just put it into S3. It's just simpler to manage, and we can build like this whole web interface to it as well. Any other questions? Okay. So yeah, key takeaways. What I really enjoyed about this project was this thing, working on a proof of concept. Like a lot of this stuff is documented heavily, nicely. I find that AWS batch documentation was really nice and good to read. But documentation only gets you a bunch of way through. They have limits on these systems. Like for example, for right now, this whole job queue and compute environments only works really well for a maximum of 3 compute environments on one job queue. Right? I couldn't find that written in documentation, but when I was trying to hook up a 4th one, it wasn't, wherever I tried, it wouldn't really process anything. It could be a bug in my code as well, but like it's things like that, right? It's all the nuances of using this system. The scheduler, it was really good with the interface and sort of telling me the status of the jobs, but I mean, it is V1 of batch. It was a bit slow, when I had like, I don't know, I only had like 100,000 jobs. It was so slow to sort of go through the interface and look at it. Obviously, I can use their API. But just saying, you're not going to be able to figure out all these nuances and all these limits of the system unless you actually try a proof of concept. So I think that's really important. Another thing that's really important for us, I don't know if all of you guys struggle with this, but we were struggling with this for a while. All of this is about data collection and data analysis, right? At the end of the day, you can say very simply that, right? Just analyze all the data. But it's like conceptually, you have to sort of define how you want to think of the problem, right? So it's like, should I use streams? Should I use Elastic MapReduce? Should I put jobs in a queue and process it? Why should I choose one over the other, right? So I think a good place to start about that is how do you, what do you think is the best way of solving that problem? So laying the ground on that, we thought of things as being a job or data parallel. And obviously on top of that, you need to figure out the actual business requirements, right, of throughput and stuff like that, and expenses, cost as well. So I think it's good to think about these problems conceptually and how you want to solve them. And I think this is very important. We have been burned by this earlier in STAT and stuff. It's you just start implementing. You're like, oh, AWS Batch is really simple. I'm just going to start throwing stuff at it and seeing what happens. It's not a bad idea, and that's what I did for my POC, right? But it's like if you're going to put it directly into production that way, I think it's a horrible idea. It's not worked for us. At least if it's worked for you guys, and you can talk to me about it, and I'll be happy to hear that stuff. What's worked for us is we sort of design a high-level architecture, thinking about okay, this is our goal. This is where we want to get with this. Now let's choose the tools and components that serve that goal. So then I think designing a high-level architecture is really important. Lastly, and this might be only not applicable to everyone here. It's like if you're working on a new project, perhaps this is not as important. But we are obviously taking our existing crawl and redesigning it, right? So thinking about it as okay, these are the different components, and how can we take an incremental approach to replacing those components? It helps us, what it's helped us in doing is having small, well-defined projects, have wins, and then move towards a final bigger goal of redesigning the entire crawl in this case. So I think it's pretty good to take an incremental approach to these things. What's next? Well, I think I was saying a bit of this earlier as well. Set up a lot more of those priority queues, different kinds of compute environments. When it does this at a much bigger scale, right now I only had, I was saying, about 100,000 keywords. 15 million is what we're doing right now, and that's growing. So I probably want to test it at least with 1 million keywords and see how that goes, if I see any other problems with it. Planning of implementation projects, we're actually, in fact, already started. In 2 weeks from now, we're going to do this. We're going to take our existing parser and move it into, Dockerize it, and move it into ECS. Just run it with our existing system and see how that goes. And from there on, we'll figure out other incremental projects as we redesign this entire system. This is just the thing about the code stuff. So yeah, I really found it cool and easy to use Docker and ECS. This here is just the spider portion. It's super easy to use it. If you haven't already, there's just these commands at the bottom there that show you how to build something and run it in Docker. And I'll be talking a lot more about this at the Code and Coffee meetup. Finally, if you are interested in working on stuff like this, right? A project that we have ongoing is the crawl as a service thing. It's probably, I'm considering it's probably going to take us at least with a team of people that we have 4 or 5 months to do it, right? And it's just at the very beginning stages. So yeah, we're looking for 2 data engineers to work on this project. After this, we're going to redesign our entire data pipeline, the analytics stuff that sort of just touched on. So that's the next thing that we're going to work on. And we're also looking for a DevOps engineer along with those 2 data engineers to work on the infrastructure pieces. So talk to me. There's a few of us also here from STAT, sitting in the front row here. So yeah, if you're interested in knowing more about us. And that's it, actually. That's it for the talk. Any more questions? Yeah, go ahead, Boris. Yeah. I mean, there's also the stories. For us, the biggest thing is testing things at scale, right? It's really hard to do that, and you don't figure out the limits of your databases, especially if you're self-managing them. We had a terrible time with the whole MongoDB situation there, right? Because you're all right, this works fine. It works fine for 100,000 keywords. Let's put it in, and it wouldn't, right? So our thing, though, is we want to, and we have started this thing. We're going to move to a lot more of managed AWS services. I mean, it's not like we are averse to DevOps and you want to do DevOps, but the DevOps you want to do is on managed AWS services rather than doing all these operations on these servers ourselves. But yeah, we've dealt a whole bunch of problems to do with scale. The other thing I would say is testing. So the whole Dockerization piece, that's why we are after that. That's why we want to move things to Docker, have consistent dev and production environments. Because small things, like, on our Mac OS X machines, the Blue Pool thing that I was talking about that actually monitors the Ruby worker kind of works differently than it does on Amazon. And then it's just not setting it up correctly with the correct params there because it's different, makes things crash. So like having consistent dev and prod environments is another thing that's bitten us. Yeah, go ahead. Yeah. Yeah. Well, okay, so when I don't know if it's really new or something, but when I was doing this stuff, there is fake SQS that mocks it, right? I mean, obviously, when you're testing at scale, you got to put it in there. But to develop stuff, I use like fake S3, like mock S3, right? And Dynamo and SQS, just to make sure like it was working fine. And then after that, it's like how I did it was like, create separate accounts in AWS and just be like, all right, this is completely isolated, my account from our production account, and I'm going to start putting, my Docker image is really easy to put up there. Right? AWS Batch makes it simple to set up SQS and stuff. I'll test it at scale there. Yeah, go ahead. Yeah. Yeah. So the transition for us, most of the headache is going to be moving all of our data over. Like, Batch, I'm not quite sure because I've not looked if there's something similar in Google Cloud. There probably actually is. So that's not going to be a big issue. Docker, they all have a similar thing to run Docker containers on. They have queuing system and very other similar technologies. We are locked into AWS for the most part is because we have a lot of data, like 7 years worth of data in there, right? And so, like, we could probably ask them, they have these services that they'll ship us hard drives, and we can ship them to Google, right? But doing it over the network would just suck. But like in terms of technology, there isn't that much of a lock-in. At least I don't think so. But like I haven't done it. So like, take it for whatever it's worth. Yeah, go ahead.
How many Docker images do you have?
Right now, I just have those two, the spider and the parser, for the proof of concept.
I guess having two, you don't have to worry about how you manage those, right? So if you want to introduce a new change,
Yeah.
do you have any tools in place which help you to manage those?
Yeah. So yeah. So obviously, we haven't. It's a POC that I did with the spider and the parser. But in ECS, you can set up Docker repositories, as many as you want. Right, and that's what I'm doing. I'm like working with my Docker container on my local machine. I make some changes, right? It creates, just like how Git or any of the repositories work, it creates a diff, and it uploads just the changes to the Docker repository in ECS. So it was fairly painless. Docker is really good. I forget what exactly they call it, but they create those layers and figuring out the changes between the layers. They do a good job and just upload those megabytes that have changed in the layers. So it was easy to do that, and the repositories were good enough to manage. I mean, the code, you need to have a separate repository, obviously, right? Like you'll be probably putting it in GitHub or something like that.
I was just more curious about, let's say, your image. You want to install new version of the software, right?
Mm-hmm.
And maybe the process of how you build the image is much more complex. It has
Mm-hmm.
20, 25 different steps.
Mm-hmm.
Obviously, it's pretty inefficient to do it by hand.
Mm-hmm.
Usually, companies prefer to have some sort of tools in place
Yeah.
which they can use to do them.
Yeah.
Puppet, Ansible, whatever.
Yeah, I see what you're saying. See, the thing is, the Docker images that I had were very simple. Right, you know, I was just installing, I used, and I'll talk more about this at the meetup, right? I was using a headless crawl browser using Nightmare. So I just got one of those Node.js Docker images, installed Nightmare on there, and that's it. That's all I needed. One of the things that we will do to maybe get away from this whole idea of chefing those Docker images using something like Puppet is have as small discrete services as possible with the least amount of software to install on them. And we can do that. I know everyone can't. Our spiders, parsers, and rankers are very simple. So that's probably how we'll do it. Any other questions? Yeah, go ahead. Yeah. 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 Yeah, so if the spot instance, well, okay, so if the job is running, at least in my experience working with it, the job will finish. Like that particular job will finish. It's not like I haven't encountered a case where they'll fail the job midway through and the spot instance will go away. After the job is finished, though, yes, the spot instance might go away. In that case, the way I was setting it up was I had two compute environments. One was not spot, one was on demand, right? And so that one will pick up the jobs until then another spot instance is available on the secondary compute environment. Okay, so the jobs, in my experimentation, would always finish. They're really tiny jobs, though. Like the jobs I'm talking about, they finish in a matter of a second. Right? So like, the computer environment has been created, the job finishes in that second, and then the computer environment might disappear. It doesn't actually pull the job from the queue, from my experience. I believe if it did, yes, it would fail in the queue, and then that's why the retry mechanism will just pick the next compute environment, and it'll try that job. There is this thing, if I have a retry of 3 and it fails more than 3 times for whatever reason, then the jobs are like dead. They remain in that batch, right? And then I can investigate it and do whatever I want with it. Yeah, go ahead.
So based on my understanding, you basically create 13 million jobs.
Yeah.
And put in the queue.
Yeah.
Each spider is like a very short-like process.
Yeah.
To get things done and destroy it.
Yeah.
Is it too heavy? Every time you kind of start.
Yes. So obviously in our old architecture, they're just running all the time, right, waiting for jobs. In AWS Batch, yes, it can be heavy. Like I said, like it's not efficient in terms of the Docker. Like the Docker code is already running on a container agent on an EC2, right? And the way I did it for the POC was it was running like several Docker containers on this compute environment, so it is inefficient. When we put it into production, that's one of the things we'll probably investigate, because we can run multiple workers on the same Docker instance. Like we haven't done that. I didn't do that, but that's probably one way of gaining more efficiency. For us, though, since we'll probably be we're running it right now 24 hours a day, just reducing it to the time we crawl, which is about, like I was saying, like about 16 hours a day. That in itself will be a huge cost saving. We'll add spot instances on top of that for additional cost savings. So I don't know. We'll have to budget it out. But in the end of the day, it might actually be cheaper, and it's all self-managed.
Why you don't create a daemon to crowd the website?
A daemon.
Let's say you get like 200 messages and crowd the website, and meanwhile get messages at the same time.
Daemon to crawl the website.
Yeah, usually crawler is a daemon, right? So pulling a message from the queue and crowd the website using asynchronously.
Yeah. So that's what. Okay. So yeah, the whole thing, the business piece here that I didn't really get into, and we can probably talk about it afterwards. Actually, is the fact that we need lots of IPs. Right. So that exactly doesn't work because of the fact that Google will probably block that. right? So we need IPs to route our requests through.
That's why you're launching all new instances with different IPs.
No, that's not the reason. We have our own IP infrastructure that we're using for that. But there are a set of IPs that we're using, and we can only pick IPs, right, at a certain time. So we can't do the daemonization the way you want. It would be a good idea and it'll probably work if you didn't have this thing.
Because with my experience, I mean, a single person, it's quite efficient, especially use the synchronous IO
Yeah.
to create different websites.
Yeah, you could do that, but like I'm saying, I can discuss it about more detail with you afterwards. Some of it, in fact, I'm sorry I cannot, but I'll try to explain how much I can, because it is intellectual property, the whole. That's a secret sauce that makes us crawl, or gives us the ability to crawl 15 million keywords every day.
Maybe to follow up on what he's saying, so like at the moment every job is a single keyword.
Yes.
Ever thought of patching them together with a or something?
Yeah, we've tried all those sorts of experiments. It's either leading us to like bad quality of data, because sometimes it hits the case of personalization, right? Because it's not only the fact that you have to be logged into Google to get personalized results. It's just, it has a mapping of your history. In other cases, we sometimes encounter them blocking us and stuff like that, so. I mean, this is obviously like an open-ended question, right? We're trying to optimize it as much as we can. At the end of the day, sometimes it's just not worth it. Yeah. All right. Okay, thank you, everyone.
Yeah, thanks so much, Anish. That's really great. So after this, we are actually going to move over to have some drinks and share some stories. Any people have thoughts around this, we're welcome to discuss. So the original destination that we were talking about is Blackbird, which is just a block down. But unfortunately, they don't have any space for a group as big as us. So I actually found a space which is 2 blocks further down north on called Butcher and Bullock. So yeah, everybody, we can grab some food and grab some drinks, and welcome to hang out. Thank you very much for coming.